Right, solutions to problem 4 from Math 95. We're given this function here, f of x. It has to do a bunch of things. So first we want to find f of 3. So figuring out f of 3, you can kind of look at this function here and sort of just replace all the x's with 3's. So instead of 22 minus 2x, it's 22 minus 2 times 3. And then from that we subtract 1. And so let's see, 22 minus 2 times 3 is 6. 22 minus 6, 16. Square root of 16 is 4. So what we get is that f of 3 is 4 minus 1, which is just 3. Okay, part B, find all values of x such that f of x equals 3. So often I ask these guys in conjunction because they look really similar, but they're asking different things. This is saying we want the output of the function to be 3. We want this entire thing, the square root of 22 minus 2x minus 1, to be equal to 3. We want to solve for x. So we can do that. First we want to isolate the square root sign, so add 1 to both sides of the equation. Then we want to get rid of the square root sign, so square both sides of the equation. Now we want to isolate the x. One way to do it would be to subtract 22 from both sides. Oops. Subtract 22 from both sides, and we're left with negative 2x is equal to negative 6. 16 minus 22. And then divide both sides by negative 2. And get x equals positive 3. I guess on these square root problems, you really should check your answer. You should take this 3 and plug it back in. Make sure it works. In this case, it will. How do we know it will? Well, if you put 3 into this function, that's exactly what we did in part A. In fact, when you got your answer from part A, when you said f of 3 was 3, we already figured out the answer to part B too. Find all values of x so that f of x equals 3. It's this guy here, it's 3. But I didn't expect you to see that. I kind of want you to go through the work and do it. C, find the domain of f of x. So for the domain, what we need is there's 2 domain rules. You can't divide by 0. Well, 2 in our class. You can't divide by 0, and you can't take the square root of a number that is negative. Turns out you also can't take the logarithm of a number that's not positive. But we don't deal with logs in our class. So for our purposes, since we're not dividing by anything, all we have to do is make sure 22 minus 2x is not a negative number. In other words, it's greater than or equal to 0. So we have this inequality we can solve. Well, let's see, a couple different ways to do it. One way to do it would be to subtract 22 from both sides. And then divide both sides by negative 2. Negative 22 divided by negative 2 is positive 11. But be careful, anytime you're dealing with an inequality, if you multiply or divide both sides of the equation by a negative number, you've got to flip the sign around. So my domain is all x's that are less than or equal to 11. In other words, everything from negative infinity all the way up to 11. And I want to include 11 because it's less than or equal to 11. Here's my domain in interval notation. All right, part D. Sketch a graph of f of x by completing the table below and then plotting those points on a graph and connecting the dots with a curve. Okay, so I need to know when x are these values, what are f of x? So I need to figure out f of negative 7. I probably shouldn't try to squeeze it in here, but I'm going to. It's the square root of 22 minus 2 times 7. No, 2 times negative 7, sorry. Placing x with negative 7, minus 1. 2 times negative 7 is negative 14. 22 minus negative 14 is 36. The square root of 36 is 6. 6 minus 1 is 5. In other words, f of x is 5 in this case. You might want to show a little bit more work than I did. F of 3, we already figured that out, it's 3. F of 9, similar, square root of 22 minus 2 times 9, minus 1. 2 times 9 is 18. 22 minus 18 is 4. The square root of 4 is 2. 2 minus 1 is 1. And one, again, you might want to show more work. Don't have to. I don't really care. F of 11. 22 minus 2 times 11 minus 1. Well, 2 times 11 is 22. 22 minus 22 is 0. Square root of 0 is 0. 0 minus 1 is negative 1. So now that we have these values here, I can kind of do part D. I can create a graph. Let's see, I want my x's to go at least up to 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And at least down to negative 7. Good enough. And then the heights, it looks like 5 is as high as this thing ever gets, so I can space these out a little if I like. Good enough. Plot all these points. When x is negative 7, y is 5. Here's negative 7, here's 5. When x is 3, y is 3. 1, 2, 3, 1, 2, 3. When x is 9, y is 1. Here's 9, here's 1. And when x is 11, y is negative 1. So I'm right in here. So these are all my points. What did I say to do? Sketch a graph of f by completing the table, done. Plotting those points, done. And connecting the dots with the curve. Okay, so you're not supposed to know what the graph looks like. You just know that it goes through all these dots. So you can kind of blindly connect them with the curve. And maybe you'll get something that looks, man, that's hard to do on a computer. Something like that-ish. Turns out that's exactly what it looks like. It's kind of this curve, gradually decreasing curve. So this is the graph of this function, Turns out it's this right here. We'll learn in 111 how to come up with this immediately, not by plotting points. But for now, this is the best we can do. So I guess that's the end of this perfect problem.